Hey, what's going on, guys? So technology has so many different areas, as you know, and when it comes to programming, there's so many different languages to learn, and it can be quite overwhelming, especially for beginners. So what I wanted to do in this video was basically a crash course of programming languages and just go through a lot of the modern languages and talk about what they're good for, how they work, and also look at things like low level versus high level and what that means. Talk about compiled versus interpreted languages, statically typed versus dynamically typed. So it's going to be a little more than like a top 10 programming language video. And I think that it'll help a lot of beginners, and even for people that are looking to learn a second or third language, I think it can give you some good insight. So I'm going to jump into some slides just so I can better convey the information. So hopefully you guys enjoy it, and let's get into it. All right, guys, so before we get into specific programming languages, we should first talk about low level versus high level. And when I say level, I'm really talking about the comparison between the language or the code that we write and the machine and what the machine understands. Because your computer doesn't directly understand JavaScript or C# or Java or anything like that. It has to be compiled into something that the CPU understands. So when I say levels, I'm basically talking about how close to the hardware the language is and how much abstraction there is between them. So you can almost think of the hardware as the lowest level. Up from that, we have machine language or machine code, which is the absolute lowest level of code, which consists of instructions that are used to control the machine's CPU or central processing unit. And these instructions are strictly numeric, and they're in the form of zeros and ones, which is called binary. Machine code can also be represented as hexadecimal, so it's easier for humans to read, but ultimately machines only process zeros and ones because it represents an electrical state that's either on or off. All right, now programmers don't write machine code, at least anymore. I guess you could, but it would be very tedious and very error prone. And I don't think there's many companies hiring senior machine code developers. All right, so the next level we have up from that, I should see the next language we have is called assembly language, or ASM, or just assembly. And assembly uses numbers, symbols, and abbreviations as opposed to just ones and zeros like binary machine code. And assembly code isn't actually compiled like some of the higher level languages. It's converted or assembled into executable machine code by something called an assembler. Compiling, which I'll talk about soon, is a much more complicated task than assembling. A lot more goes into it. And you can learn assembly language. There's YouTube videos, there's even Udemy courses that you can take to learn assembly language. And I do think it's interesting because you really start to understand how software works with the CPU and works with your computer's hardware. Assembly is typically used today to develop software or firmware for embedded systems. Now from here, we have the next level, which consists of a bunch of general purpose languages that are pretty common. Now, in some cases, you'll see charts like this that refer to these as high-level languages like C, C++. However, that's when you're comparing it to the whole chart, to machine language, assembly language, and so on. These languages are lower than something like Python or Java or Ruby, which we'll talk about later. So let's take a look at C. C is the lowest level general purpose language. The only thing lower than C is assembly and machine code. And C was created in the early 70s by Dennis Ritchie and was actually derived from another language called B. And C was used in the development of the Unix operating system. It's a procedural language as opposed to an object-oriented one, and it's lower level than many other languages, so you do have to manage some hardware resources such as memory allocation. And I'll talk a little bit more about that in the next slide. So C is very powerful. It's used for things like operating systems. The Windows kernel, for instance, is built with C. It's also used to build compilers for other languages. It's used for drivers, database systems, and many other powerful programs. And C is also a compiled language. So before we move to the next language, let's talk about compiled versus interpreted languages. So a compiled language requires a piece of software called a compiler, which will compile the code that you write with a language like C down to instructions that the machine understands. So the compiled program is not human readable, it's meant for the machine, and it's executed by the CPU. Now, usually with lower level compiled languages, such as C, you have to manage your memory. So memory allocation, CPU usage, you have more access to the hardware, but of course it's more difficult to work with. With an interpreted language, the source code is not directly compiled to machine code. There's more abstraction to it, and a program called an interpreter reads and executes the code. In some languages like Python and Ruby are first compiled into some sort of bytecode, which are binary instructions that are executed by a virtual machine, such as the Python virtual machine. Technically, they do have a compile step, but they're not being compiled directly to machine code like with a lower level language like C. So we usually refer to those as interpreted or scripting languages. Now, interpreted languages are typically easier to work with and allow you to write code faster, so there's a fast write time. However, there's more abstraction than with a compiled language where your code is simply compiled directly into machine code and executed. So this makes programs faster at runtime for compiled languages. And of course, this isn't all you're going to look at when choosing a language. It's just good to know the difference. So the next language we're going to look at is C++, which is another lower level language that was created in the 80s. And it's actually a superset of C, meaning that it is essentially C, but it has a bunch of extra tools. So C++ is actually object-oriented, which is a coding paradigm based on the concepts of objects. And like I was talking about in the last slide, both C and C++, there's no what's called garbage collection, which means that you have to manually allocate and free memory within your code. So C++ is an incredibly powerful language. It's used to build things like AAA gaming titles, operating systems. It's used in VR, robotics, scientific computing, and stuff like that. So if you're interested in those types of, or that part of technology, then C++ might be something to look into. All right, so Rust or Rustlang is a relatively new low-level and high-performance language that provides higher-level capabilities, and it provides protection to keep you from making mistakes with memory allocation. So that there is no garbage collection, but there is protection built in, more so than something like C or C++. And Rust can be used for game engines, operating systems, browser components, VR, and much more. And it can be used to create web servers and used in the back end for web development. You can create APIs and microservices with Rust. It has some frameworks like Rocket, which will help you build web applications. And one area that I think Rust is thriving in and will continue to thrive in is WebAssembly. So WebAssembly is a new type of bytecode that can be run in modern browsers, and it provides very high performance within the browser, much higher than what JavaScript can give us. So there's a few languages that can be compiled into WebAssembly, including C++ and Rust. And I think WebAssembly is going to be huge in the future for things like gaming and video tools within the browser. So learning Rust may be a really good idea if you're into that kind of thing. All right, so we're going to move to some even higher level languages, most of which are interpreted. So they're not quite as fast in terms of the software you build, but they're generally easier to learn and extremely popular in the industry. Since this channel is focused mostly on web development, these are probably the language that you're going to be choosing from. Also, I do want to mention that there are other lower level languages that are, on this level here, such as Pascal, but I don't want to make this video too long, so I'm not going to talk about every single language in existence. So next we're going to look at Java. So Java is a high-level, class-based, object-oriented programming language. Everything you create in Java is essentially an object or part of an object. And objects are defined by classes that have variables, which are also called properties, and functions, also called methods. So Java is a what's called a write once, run anywhere language, meaning that compiled Java code can run on all platforms that support Java without the need to recompile. So Java code is typically compiled into bytecode that can run on what's called the JVM, or the Java Virtual Machine. And I'm sure that you guys have all have installed the JVM on your computer at one point or another. So Java is used for a lot of different things, including graphical, desktop applications, enterprise applications. Java is still pretty popular in big business. It's also used for web servers and APIs. It's used for mobile app development, specifically Android apps. Google uses Java for many of its products. Minecraft was created with Java, and companies like Spotify, LinkedIn, Amazon all use it in one form or another. Java is also statically typed, so this is something else that I wanted to talk a little bit about before moving forward. So every general purpose language that we've talked about up to this point is statically typed. And what that means is that the type checking is performed at compile time, and we have to explicitly define types for our data within our code. So for our variables and our function returns, if something is a string, we need to define it as a string, and it can't change into a Boolean or some other type. Now, dynamic languages such as JavaScript and Python, which we'll get to soon, do not require us to define types explicitly, as type checking is done at runtime. So it basically assumes the type automatically or dynamically. As far as which is better, there's trade-offs with dynamic languages. You don't have to worry about, typing everything, so it's less code. However, statically typed languages can be less prone to errors and can be more robust. So just keep that in mind moving along. And I know that I have a lot of JavaScript developers as viewers, and you can just think of, JavaScript versus TypeScript, because TypeScript is JavaScript with static typing. All right, so I wanted to mention Kotlin right after Java because it also uses the Java Virtual Machine, the JVM, and it's also used for Android apps. In fact, most modern native Android apps are built with Kotlin. If you're looking to learn Kotlin or Java, I'd probably suggest Kotlin because of its popularity, and most people say that it's easier than Java. I don't really have any experience with Kotlin, but it can be used as an object-oriented language or procedural code. In addition to mobile development, it can be used for web servers, data science, and much more. So as far as who uses Kotlin, you have Cash App, VMware, PlanGrid. These are some examples of services or companies' products that use Kotlin.
Thanks for watching. Please subscribe and check out the next video for more clarifications on different levels of programming languages. See you then.